Right, hi everyone. My favorite topic, just my favorite topic, I think, is moments here, statics. Moving on to hinges and ladders. That's what we're going to get into. But before we do that, we're going to do some practice of calculating moments at different angles and stuff. So you would have just done beams, where everything's very flat. But now we need to just get back into this idea of finding the moments when you've got different angles. So we know that tau is FD, right? Where F is the force and D, very important, is the perpendicular distance from the force to the pivot. So if this is F and this is our pivot, right? And this is like some door that's being pushed, right? So actually, that's what I should make a dotted line. So dotted line, here's P, there's the pivot. This is the door, the dotted line, and someone's pushing on it. It's always the distance, the perpendicular distance from the force to the pivot, D, okay? So what we're going to do is, here's our pivot point here, here's the hinge. These dotted lines, they're just, imagine they're various kind of doors, like, so you've got some kind of, if this is a bird's eye view, a triangular structure attached to this pivot, and various things are pushing and pulling against it, right? I want to know if it's going to turn clockwise or anti-clockwise. So what I need to do is, I need to first find the moments clockwise, right? So look at all the things that are turning clockwise. Well, the only thing that's going to turn clockwise is this 5 newtons here, right? Some people find it quite difficult to know where is it going to go anti-clockwise. Basically, if the arrow is going up to the left, then you just need to imagine it circling around. Where if it's going down on the left, well, that's coming down around the pivot, you see? So I would just continue things around that way. So this 5 newtons, we're just going to tick it off. So we just write force, immediately write force, and then we need to decide what's this big distance here. That's the perpendicular, isn't it? How do we find that? Well, I can see a big triangle here screaming out at me, okay? So I can see that the distance I'm looking for, D, can come from sine, because it's opposite. It's opposite this angle given, you see? So this is D, the thing I'm looking for, over the whole hypotenuse, which is 4 meters. So therefore, D must be 4 sine 55, okay? And if I whack that in my calculator, 20 sine 55, that's 16.38 Newton meters clockwise so far, okay? What's the anti-clockwise ones though? So moments anti-clockwise. Let's think about this. So I've ticked that one off, that's all good. The anti-clockwise ones though, let's start with this 3 newtons here. Okay, that's 3 newtons, so I've got my force 3, but what's the perpendicular distance of that force to the pivot? You're right, nothing. It's like me pushing on the hinge itself. That's not going to make any difference. It's not going to move anywhere. It's not going to turn. Okay, so watch out for that. So that one's done. The 5 newtons going down. So I draw the pivot so it goes past. I draw the force, sorry, so it goes past the pivot point and makes that right angle with the pivot, yeah? So my force going down is 5 newtons. There's our 5. But then what's this distance here that I'm looking for, this x distance? Well, bit tricky at first to look at, but if you see that distance and that distance is actually the same, so I can use this little triangle to tell me that. And again, it's sine, isn't it? Because it's opposite the 55. So I am going to start getting quicker with that, but sine 55 is the distance I'm looking for over 2 meters. So this is 2 sine 55. So notice if the angle is opposite the length I'm looking for, I'm just going to go hypotenuse sine 55, or hypotenuse cos the angle, right, if it's next to the angle. So that's that 5 newtons ticked off. What else do we have left? We've got this final 3 newtons at the top, and this is going anti-clockwise, right? So again, force, and then perpendicular distance from the force to the pivot. So I need to know this big Y here. So I've got plus force, which is 3. And now what's this big Y distance? Well, again, I'm using the big triangle again. So I'm straight into, here's my angle, it's y is next to the angle. So I'm going to go hypotenuse, which is 4 cos 55. And that's all the forces dealt with, you see, you tick them off. So if I do that, so that's 10 sine 55 plus 12 cos 55. I get 15.07 Newton meters, and this is going in the anti-clockwise direction. So which way is it spinning overall? If you've got some people pushing it clockwise, some anti-clockwise, well, this is where the sum of moments comes in. So sum, highest take away the lowest, and we see that 16.38 minus our answer is 1.31 Newton meters, and it's going in the majority clockwise, okay? So in the end, it's spinning with 1.31 Newton meters clockwise. Let's do another one. Again, this is just abstract problems at the moment, but if you can do this, and you'll do a lot of these in class with me to practice, then it really starts you getting in the mentality of, it makes the moments in hinges and ladders much easier. So here's our pivot this time. A little bit to think about then. So let's locate our moments going clockwise first. So which ones are going clockwise? Well, this 3 newtons is going clockwise, so let's deal with that. Here's the pivot. So I put my right angle, so I put my force past the pivot, and this is the distance I'm looking for, all right? So force is 3, and now I've got my distance. So if that's 40, here's a Z angle, that must be 40 as well. And I'm looking for the adjacent one. So I should be saying immediately that's cos. So hypotenuse, this whole thing is 6 cos 40. Fantastic. So that one is dealt with. Any other clockwise ones? Well, looking at it straight away, this 2 and 1, that's directly pulling the hinge. So the perpendicular distance from them is 0. So I don't even need to consider them. So I'm just going to not bother with them, right? So it looks like the only ones left are anti-clockwise ones. So at the moment we've got 18 cos 40, which is the same as 18 cos 40, 13.79 Newton meters clockwise. So notice I'm always stating my direction. And then if we do the moments anti-clockwise, we can compare. So anti-clockwise, what have we got? We've got this 2 newtons on the bottom. So again, I always draw it. Notice I'm drawing the arrow past the pivot point and making that right angle really clear. And I'm looking for that distance y. So I've got force 2. You just write the force direct. And now I need that distance y. Well, how am I going to get that? Well, there's a triangle sticking out right there. So the angle 58 is opposite y, so that must be sine. The hypotenuse is 4.5, so 4.5 sine 58 degrees. Plus, so that's that one dealt with. Now we've got the 5 newtons. So this 5 newtons here. So again, I draw my force past the pivot point, and then make a right angle to that pivot. And this is the distance I'm looking for, x, okay? And I can clearly see it's this triangle I'm working with. So my force is 5 newtons, so 5. I've got hypotenuse, which is 3, right? There's your 3 there. And the angle is next to 40, so 3 cos 40. Okay? So that's all of the forces dealt with. So if we add those together, we're going to have 9 sine 58 plus 15 cos 40. So that's 19.12 Newton meters anti-clockwise. And therefore, which way is it spinning? Well, the sum of moments, 19.12 take away 13.79. It's spinning 5.33 Newton meters, and the greatest is anti-clockwise. So this thing is spinning anti-clockwise. Okay? Now, if we understand that, we can move on to hinges. I think I'm going to make this a different video, actually. Okay? So that was how to do moments and how to decide whether it's sine or cos.